the James Webb Telescope has revealed a groundbreaking discovery. Instead of just a few, it has exposed hundreds of ancient galaxies that could be among the first members of the universe. This is a significant leap from the limited number previously known to exist at that time. According to a recent study, these very young galaxies exhibited complex structures and clusters of star formation as early as 600 million years after the Big Bang. The study is part of the JWST Advanced Deep Extragalactic Survey, an international collaboration. JADES collected a month's worth of observations from two specific patches in the sky, one in the Ursa Minor constellation and another in the direction of the Fornax cluster. Within these regions, over 700 newly discovered young galaxies provide insights into what the cosmos looked like in its earliest stages. If we could compress the entire history of the universe into a 2-hour movie, what we're witnessing now is akin to the first 5 minutes. In simpler terms, these galaxies represent the early stages of creating the fundamental elements and intricate structures that define our world today. These new findings shed light on how the first galaxies and stars formed, creating the rich catalog of elements observed in the universe today. In those 5 minutes alone, which marks the universe to be between 370 million and 650 million years old, scientists studying Webb's data found 717 young galaxies, which turns out to be higher than previous predictions, with all of them already spanning thousands of light years, sporting complex structures, and birthing stars in multiple clusters. Despite this previous scrutiny, 93% of the newfound galaxies that Webb spotted during JADES had never been seen before. Hundreds of tiny, colorful galaxies against a background of deep space. Precisely how that chaotic, very dusty environment cleared up to become the transparent cosmos we see today has long been debated. A leading theory is that this phase of evolution of the universe, called the Epoch of Reionization, occurred some 400,000 years after the Big Bang, when the first generation of stars, thought to be 30 to 300 times our sun's mass and millions of times more bright, formed and flooded the opaque universe with its first light. That ultraviolet starlight reionized the universe by splitting its abundant hydrogen atoms into protons and electrons, a process that lasted until 1 billion years after the Big Bang. However, few astronomers say outflows from supermassive black holes, similar to the one that resides in the heart of our Milky Way, could have triggered the escape of ultraviolet radiation from galaxies and thus played a more important role in cosmic evolution than previously thought. Now, a second team from the JADES program that has been studying galaxies that existed between 500 to 850 million years after the Big Bang, or between 5 to 8 minutes of the 2-hour movie describing the universe, thinks it has an answer to the long-standing question. In this next scene of the universe, we are starting to actually see the impact of galaxy formation on the composition of the large-scale universe. Galaxies in the very early universe were just far more chaotic in general in how they formed stars. Scientists studied the signs of star formation in those very early galaxies, which provided insight into how starlight ionized the gas within those galaxies. They found that 1 in 6 galaxies at the time showed extreme line emissions in the galaxy's spectra, a feature that atoms ionized by starlight radiate when they have cooled down and combined with other molecules. Those emission lines are evidence that early galaxies were actively birthing stars, which then pumped torrents of ultraviolet photons into their respective galaxies. This way, the universe's early stars became the main drivers of cosmic reionization. These extreme emission lines are relatively common in the very early universe. Almost every single galaxy that we are finding shows these unusually strong emission line signatures, indicating intense recent star formation. These early galaxies were very good at creating hot, massive stars from the same emission lines. Galaxies in the early universe birthed stars in short bursts followed by quiescent periods. Suddenly you would have tens of suns worth of solar masses being assembled all at once in these early galaxies. That's important for our understanding of how reionization happened, because these hot massive stars were very efficient producers of these ultraviolet photons that we needed in order to ionize all the hydrogen in the early universe.